Bien, le damos la bienvenida a nombre de SERC Chile, además de la Universidad de Talca y el Centro de Energía de la Universidad de Chile, que se han sumado para tener este ciclo de charlas con invitados especialistas en distintas temáticas de interés en el área de energía. Como saben, nos estamos reuniendo regularmente y agradecemos siempre el que nos acompañen en estos desafíos. Hoy día tenemos el gusto de recibir a un nuevo invitado en el área especial de agrivoltaica, pero justamente tenemos al director de CSET en Chile de Fraunhofer, al profesor Frank Winter, que va a hacer las palabras introductorias a nuestro invitado de hoy. Adelante, Frank.
Gracias, Rodrigo. Buenos días a todos. Como Rodrigo ha dicho, yo soy también profesor a la Universidad de Chile y para mí es un honor esta mañana presentar nuestro especialista, David. I will change to English because this session is in English. David is our specialist in integrated PV applications, and he works on urban farming. He works on floating PV and also on agri PV. And today he himself is a mechanical engineer, and he's looking for systems in renewable energy which are also very useful for Chile, which we can transfer technology from Germany to Chile or from Europe to Chile. And so I'm very happy, David, to listen to your presentation today.
Yeah, thanks, Frank. Buenos días a todos los que están aquí. Voy a dar ahora mi charla en inglés, pero cualquier duda o pregunta que tienen, igual podemos comenzar luego en español, no hay ningún problema. Ahora, I will switch to English now. I will share my screen, and you can give me a brief feedback if you can see my screen. Nicolas, do you see the screen?
It's okay. No problem.
So, hello everybody. Also from my side, thanks Frank for the brief introduction, and thanks at SERC for having me here. My name is David Jung. I'm a research engineer at Fraunhofer Chile Research, the Center for Solar Energy Technologies, and I'm very happy to share a little bit about agrivoltaic, the practical experience we have made here in Chile and the potential we see for those kind of systems. I prepared 3 blocks of presentation, and I will leave some room for a Q&A in the end. But first, I will briefly explain what is Fraunhofer CSET doing in Chile. Then we will talk about agrivoltaic as a dual use of land concept, and then finally get into more details. Agrivoltaic in Chile, the pilot plans we have, what is the research we're doing, and what is the potential we estimate for this technology. So to start off, for those of you who don't know Fraunhofer, Fraunhofer is a German institution founded over 70 years ago. And since then, we are dedicated at applied research. That means we understand ourselves as a bridge between universities and the industry, taking the results of research in the academic world and looking for an application of these results in the industry. And on the other hand, we also always are in contact with the industry to look what are their needs, to mirror those needs to the research, everything with the aim to generate additional value through research. In Germany, Fraunhofer is a very big institution. Currently, there are over 70, or there are exactly 75 institutes operating with very different focus. So there are some research centers of Fraunhofer which dedicate their research to, for example, production, to optimization, to communication systems. But there's also one center in Germany dedicated at the research regarding solar energy. but in general, it's very diverse. There are 29,000 researchers and engineers working at Fraunhofer with a total budget of over 2.8 billion euros, generating more than 2 patents every day. Yeah, but Fraunhofer is not only active in Germany, also worldwide. Here we see a map. And what we see when we shift our attention to the bottom left, that here in South America, there are some project offices in Brazil, and there is a center in Santiago de Chile, a research center, which is the Center for Solar Energy Technologies, which was founded in 2014. Yeah, here you see our small but very dedicated team, which is researching in 3 areas: solar PV systems, that's where I am working, where we see integrative PV concepts, but also we are obviously helping and offering services to the commercial PV projects, maintenance of big PV parks, and for example, looking to how we can keep the generation high in big scale, utility scale PV parks. Yeah. Then we also have a solar thermal team and a team for business development. This is the brief context. If you have more questions on our work of Fraunhofer Chile, you can also reach out to me or to Frank directly. Now let's talk about agrivoltaic as a dual use of land concept. Yeah. Here I have a drawing, a sketch for you, which was actually the first time agrivoltaic was proposed. Yeah, and here the idea is, as you can see, to combine the collection of solar irradiation for photovoltaic generation and the cultivation of agriculture on the same land. The idea was that since sometimes I'm mixing Spanish, as you see, but the idea was from the beginning to create this double use of land, because as we all know, or most of you may know, when you have PV panels and you want to install them, you normally arrange them in lines. Yeah, you make lines of PV panels, and then you will leave a spacing between these rows. And in the space between the rows, there will always be some sunlight reaching the ground. And the idea was to make use of the sunlight which is reaching the ground. So in the year, and actually it was in 1981, so a long time ago, 40 years ago, it was proposed to elevate the PV panels in a height of a few meters and cultivate potatoes below them. Since then, obviously, a lot has changed, and especially in the last 10 years, it was really extraordinary what has happened to the solar energy sector. So the costs of PV, they really came down a lot. Now here, this headline says that they came down 82%. Yeah, sometimes you read that now you just pay 1/10 for a solar panel than what you have paid 10 years ago. And in some places in the world, and I think Chile is definitely one of them, solar energy is the cheapest form of electricity. Yeah. So not surprisingly, the capacity of solar PV systems worldwide went up in the last 10 years. And now just reflect on when the concept of agrivoltaic was proposed. It was at a time there was no PV sector, there were no commercial PV parks. It was just a little bit crazy idea. Since then, a lot has happened, as I show you here, and consequently, some plants have been constructed, especially in the last 10 years. What I show you here is a very similar plant from Fraunhofer ISE, very similar to the original idea. Yeah, you have here, we have PV panels installed in a fixed way. Yeah, they're fixed, not moving, in 6 meters over. And here you see there are the potatoes, but also so you see that there are other crops cultivated below. Pilot plant from Fraunhofer ISE, which they use for research. Yeah, but we will talk about research later on, and we will talk more in detail about the research we are doing here in Chile. Now I just want to show you some more agrivoltaic plants. This is also an agrivoltaic plant. And here we have the panels not installed in a fixed way, but here the panels are moving. Yeah? They're installed over vine grapes, and obviously you can, the moving panels, the dynamic panels, they help to maximize the solar irradiation reaching the panels. But also you could use the tracking of the panels to optimize the solar irradiation for the crops. Yeah? This would be a possibility. Then you can also generate double use of land like this. Yeah, you can install PV panels in arc-shaped form over, for example, here land where you have chicken. Yeah, and then here is another example of an agrivoltaic plant, which is also allowing a double use of land, where they installed vertical bifacial PV panels on a hay field. Yeah, that means that they have installed the PV panels here, which generate electricity from both sides, and they still can use the land between the rows of PV panels, and they are nearly not losing land due to the PV installation. They can use this land to cut the grass, and in the end to feed animals with the grass they cut. The point I want to make, the first point I want to make, is that agrivoltaic itself is as diverse as agriculture itself. There's not just one solution. This is agrivoltaic and this will always be agrivoltaic. No, agrivoltaic is always adapting to the agricultural, but also to the climatic context. We'll talk about this later on. Second point I want to make is that agrivoltaic aims at creating a benefit for the farmer. What does that mean? Here's one example also from Fraunhofer ISE in Germany, where they installed semi-transparent PV panels over apple trees. Yeah, and they do this because normally they put over the apple trees, they put plastic cover. We also see this here in Chile, that farmers or fruit growers, they regularly put plastic cover and netting over their trees to protect them. Sometimes when you go more to the south, they protect against the rain and the hail, but sometimes they protect also against sun or wind. And here we have the protection of the apple trees with those semi-transparent PV panels, which are also in this case moving. And in this place in Germany, they have problems with hail. So the primary protection is against hail. A similar approach was chosen here in the Netherlands, where they also protect with semi-transparent PV panels raspberries. Yeah? Also with the aim that normally they would use a plastic cover for wind and rain protection, and now they can do it with the PV panels. And here is another example from Italy, where they combine this netting which are used for some crops, and they can also use netting, for example, to protect against birds. Yeah? And here they combine the netting with the substructure of an agrivoltaic system. So summing up the general part about agrivoltaic, yeah, we see agrivoltaic is a concept which aims at allowing a dual use of land. And when we look at the current trends, as of now, we see that there's a growing interest worldwide, especially in Europe and in Asia. We see that there are many situations where they have a context of land use conflict, which means that for the PV systems, you need obviously lots of land. Yeah? And with the goals of the renewable energy, renewable energy goals, we need lots of land, and then we sometimes come into conflict with agriculture, because agricultural land is also important, and then you have where do I use my land for? And here agrivoltaic obviously is offering a very nice solution, combining both sectors on the same land and also generating synergies. We also have seen that agrivoltaic is as diverse as agriculture itself. Yeah, there's not just one solution. It can be many, and there will be many more solutions that will be developed. And we see a current trend also that agrivoltaic systems focus on providing a benefit for the farmer, not just integrating both sectors on the same land, but doing something good for the farmer. This general part. Now let's look at Chile. Yeah, let's look at the research and the potential for agrivoltaic systems. Most of you, I think, know where Chile is, and they know where Santiago is. We have installed 3 pilot plants here in the rural area of Santiago, in Lampa, Curacaví, and El Monte. Yeah, 3 pilot plants. They look like this. They have the same technical characteristics. Fairly small plants made up out of 48 panels, 12.5 kilowatt peak capacity. Polycrystalline panels. They were installed 5 years ago, and this was the industry standard, in a fixed way, in the height of nearly 4 meters, covering a ground of 224 square meters. Here you see a picture when we finished the construction of the pilot plant and passed it to the farmers, yeah, who are now, yeah, this was a project done with a financing of the regional government, and now the energy the plants are generating is connected, or the plants are connected to yeah, the houses of the farmers, and also a packing system close by, and so the farmers, they are, yeah, enjoying the clean and free solar energy the system is providing, and are also using the land below the agrivoltaic plant for cultivation. And so we, as Fraunhofer CSET, we are using these pilot plants as of today to gain practical experience. Yeah, and one practical experience, which is obviously very important, is the yeah, how can the farmer work with this plant? And here we see that they're using big machinery, a tractor with a plowing system to prepare the land. And as of now, we have no problems. And actually, they say no, it's no problem to work below the plant. Yeah, they work more precise than one would think with this machinery. And as of now, we don't have any collisions with the substructure. Yeah? So everything is going fairly smooth with respect to the work below the plant. And then there was one impact which we didn't expect. Now, nobody thought on this before, but they tell us that they love to work below the PV panels. And we all know that in Chile, especially in the summer months, the sun can be quite intense. Yeah, it's burning from the sky and it gets hot. So when you have to work at midday on a agricultural field, yeah, it's very hard work. And so here the farmers, they really enjoy to work below the PV panels. And actually, when we are in the field, we're working or doing some maintenance, we see that when they're working on other fields, they come to the agrivoltaic plant, and they make their break below the PV panels in the shading, in the shade. But we obviously know that the shading is not only nice for the humans working, it will also have an impact on the agriculture. So what we do, we want to quantify the impact the shading or the agrivoltaic system is having on microclimate. What we're doing here, we are measuring various parameters with sensors. One of the most interesting in the beginning, obviously, is the sun availability, the irradiation below the PV panels. And here we have the data for 1 day, and we see that without the PV panel, we have this typical curve of a day without clouds. And when we look at the sensor below the PV panels, which is placed on close to the ground, below the agrivoltaic plant, we see that here we have a shading. Yeah, in the morning there's no shading, the sun is reaching the sensor, but then at one point this is the substructure is providing a shading, and then here a PV panel is providing a shading, and also in the afternoon there's also some shading. I think it's from the substructure or also from a panel. Here it really depends on the place where you're measuring. If you would measure in another place, it can be that the shading will enter here. Yeah, it can also be. It can be that the shading will enter 2 times a day. It always depends a little bit on the place where you are measuring below the PV panel. But which is true for all of the points, is that when you do the integration of the solar energy reaching a point below the agrivoltaic plant, you will have a value which is lower than when you look at the total irradiation in the reference zone. Yeah. So what we see here is the total global irradiation available over three months, and we see that the irradiation is more or less 30% less. Yeah. We also look at some other parameters. Here is one really interesting. It's the humidity of the air. Yeah, and here we saw that the humidity below the PV panels is slightly higher. Yeah, and this is really interesting because when we look into the impact on the water use, when the climate is a little bit more humid, maybe we need to irrigate less. Yeah, so this is really interesting. Those are only preliminary results, but we're looking forward to really publish this data at one point soon to quantify the impact on the humidity. And also on the temperature, for example, but we are measuring more data. Here, with respect to the temperature, we see that we don't have a significant difference between the temperature below the PV panels and in the reference zone. But what we see when we look closely at the data is that it seems that in the night, the temperature is not going down that much. And in the day, the temperature is not going that high that much. In the night, obviously, it can be that the panels are protecting the heat a little bit and keeping the heat below the PV panels. And in the day, obviously, the shading has a cooling impact. But the difference between the temperature is that here is not significant. And here is a summary. Humidity was 10 to 20% increased below the PV panels, and the irradiation 30% reduced. But we don't look only at the microclimate. We also look directly, or have looked directly, in what is the impact on the plant, on the crop growth. And here we had a measurement period where we compared the biomass of lettuce in a reference plot and in a plot in an area below the agrivoltaic plant. And we effectively have not measured a statistical difference in the biomass which was harvested. So it's really interesting, that even though we have a shading, we see that there's no loss in biomass. And actually, it would be very interesting to look at the quality of the crop, because it can be estimated, and we have heard from some farmers that they have problems with lettuce in the summer months because they get burnings on the leaves of the crop. But as we are a center of solar energy technology, we also have to look at the PV side of the system. And one really interesting subject is soiling. It's the dust accumulation on the panels, which leads to lower generation. Here we see very clean and nice panels. And here we see what happens after a few months in the summer. As we can see with the, how you say in Chile, el ojímetro, you can see that the plants are very dirty and that we will have an impact in the PV generation. And we not only saw this, we measured this. So what we did was we went in the field, we measured the PV, we connected a system to measure very exactly how much energy the PV panel is generating. We measured this, the characteristics, then we cleaned the panel and we measured again. So we know exactly how much losses we have because of soiling. And these losses we can express in the form of a performance ratio, or then we validated losses in performance ratio. So what we see here is over the summer months, from the end of November to the end of January, that the performance ratio, and the performance ratio in the end is the efficiency of PV generation. We have the solar irradiation which is available, and we calculate theoretically how much energy we should generate, and then we compare this value with the energy we actually generate. Then we have a performance ratio. So we see that here over these months, the performance ratio is going down from 60% to 40%. This is a really low value for a photovoltaic system. And then I think most of you who live in Chile know that in the end of January this year, there was a very unusual rainfall. And just by this rainfall, the performance ratio went up to nearly 80% again. So really, it's a big impact that the soiling has. And then here afterwards, you can see in the data that we went and cleaned the panels. When we did the measurement, we cleaned all the panels, and then the performance ratio went up even more to over 80, nearly 85%. When we look at this data, we can see the daily decrease in efficiency, and we can see here for several periods, up to the rainfall, between rainfall and the cleaning, and between the cleaning, and we did the partial cleaning, and after this you cannot really look at the data. But we look at those 3 periods of daily losses and performance ratio, daily losses and efficiency of generation of around 30 up to 0.35% per day. This is a very high value, which in the end was a result, a conclusion of the study. We need cleaning solutions for agrivoltaic systems, especially in the horticultural sector, when they are using the tractor, when they have very dry fields and they work on the dry fields, because this dust, which is levitated in the air when they work with the tractor, is really impacting the PV generation. So this to the research. Now let's look at the potential. What is the potential of agrivoltaic in South America or in Chile? And here, yeah, the context is really interesting. Yeah, we have in Chile, we have a strong, in South America, we have a strong agricultural sector in many countries, but the climate also is very extreme. Yeah, so we have on one hand we have the unseasonal rainfall, like the one we had in January, which is causing very high losses. Yeah, and that's yeah, this, I think this year was really extreme. But we also have not only because of the unusual rainfall, just of the normal sunlight, the sun which is shining every day, which we all know in Chile there's lots of sunshine. It's also damaging some crops. Yeah, especially here in the central zone and northern zone with apples, it's very complicated because although we have good climatic conditions in general for the cultivation and good soils, we have problems with the sunstrokes, yeah, or golpe de sol, as you say in Chile. So here the solution, obviously agriculture knows what to do. Yeah, they are protecting their crops. They protect their crops with a plastic cover, as you can see here. I think this is over cherry trees against rain, but also here we see shade netting to protect against this sunstrokes and also to use water more efficiently. Yeah. So when we know that agriculture wants shading on the lands, obviously not in every field they want shading, but there are a considerable number of fields where they require shading or where they have problems with too much sunlight. Yeah, when we know this, then it's very nice because when they want shading, yeah, a PV panel is always generating shading. So we can design an agrivoltaic plant to provide the shading they need. And there are several parameters where we can play to, in the end, design the shading. And one of those are ground cover ratio, how many panels I want to install in a certain area, the azimuth, and the ground clearance, which is the height I leave between the PV panels and the ground. When I design an agrivoltaic plant, I always have to think in the machinery the farmer will use. And obviously, I want to provide the shading similar to the shading nets. And to provide the shading similar to the shading nets, we have very good tools to calculate this. And here I show you a video of a simulation of the light distribution below an agrivoltaic plant for 2 agrivoltaic plants actually. Here we see the azimuth, the orientation towards the north, 0 degrees, and a little bit slightly towards towards the west. Yeah, and we see how the shadow is moving over one day from one side to the other because the sun obviously is moving, and this is generating a shading on the ground. When we now integrate this shading, we obtain these shading profiles. Yeah, and we see here when the plant is oriented towards the north that we have a shading which is very persistent. Yeah, we have a shading which is below the lines of PV panels, below the rows of PV panels. Yeah, and this is something which is, when we talk about this, is obviously applies to horticulture. Yeah, to the shading on the ground, but we could also simulate the shading on a crop geometry. This is in the horticultural context. The farmer does not like this. It's not convenient. Yeah, I mean, he has some places where there's lots of sun, other places where there's nearly no sun. So it's for him way more convenient to have a shading which is like this. Yeah, it's an even distributed shading where he can where he has the values between 40 and 30% in every places below the agrivoltaic plant. And this, in the end, this is a similar value similar to the value the shading net would provide. So I think we can say that agrivoltaic could enable a resilient agriculture in dry and sunny regions in Chile, yeah, to allow to protect crops. And also we have to think that when we have shading on the fields, it also has an impact on the use of water because we have less evapotranspiration. The sun will not evaporate the water as much as when we have the sun all the time. So there's a potential, yeah, and we as Fraunhofer are a leading agrivoltaic pioneer, and we are supporting the industry. Yeah, so we have several research projects with pilot plants. I showed you some examples from here in Chile, but also in Germany. Fraunhofer ISE and Fraunhofer CSET. We have 10 agrivoltaic pilot plants in operation in Europe, Africa, and South America. There are currently 10 more pilot plants under construction. They're all in Europe, Africa, and Asia. Here in Chile, we're also looking to do more pilots. And here, if you're interested in collaboration, you can always reach out to me. And then we obviously are doing consultancy and industry projects. Yeah, there are several projects in several countries where we help the industry partners. Yeah, when they want to do an agrivoltaic project, they come to us and we help them with different services. They come from design over the light simulation up to the crop assessment, yeah, or scientific monitoring. Here we help with our knowledge, which we have as well in Chile as in Germany. And now I think well in time, I will finish my presentation giving a summary upon our work, yeah, what is motivating us, what is our vision here at Fraunhofer CSET in Chile. And this is that we want to enable a local industry in Chile and in South America to commercialize agrivoltaic as a sustainable solution to protect crops, yeah, but also water and obviously in the end also the climate, yeah, making a stop to climate change with PV panels. That's why we work. We do this in agrivoltaic, and as Frank mentioned, we also do it in other projects as floating PV or urban farm PV. And yes, this is my input for this session. Now I think we have enough time to solve some questions and to discuss. So I will stop sharing my screen, but first I will show you here my contact details. So if you're interested, just take a note of my mail, and you can always reach out to me and also to Frank.
Thank you, David.
Okay, stop sharing the screen now.
If you want. Here we have some questions from the audience. I will read it. Give me a second. So the first question from Carlos Salgado is, can the photovoltaic system be connected to a grid that delivers energy to a town?
Yeah, I mean, in general, a photovoltaic system can always be connected to the grid. In Chile, depends on the size of your photovoltaic system. When you have a photovoltaic system which is more dedicated to cover the to cover your consumption, yeah, you can install up to 300 kilowatt peak, yeah, and you can connect this capacity under the net billing law. Yeah, there's net billing policy in Chile which allows you to connect, which means that you are still connected to the grid. Yeah, you can consume energy from the grid at night when there's no PV energy available, but you can also inject surplus energy which is generated by the PV panels during the day. So this is a very nice policy for small projects. And then when we talk about bigger projects, they are strictly, I mean, you can make a big project for auto consumption as well if you have lots of demand, but normally then you would do big projects to connect it directly to the grid.
Okay. And the second question is from Marcia Montedonico. And she says, thank you for the presentation. Could you explain more deeply why the humidity is reduced with solar PV?
No, I cannot. Actually, this study was done by another Fraunhofer Center for Biotechnology. Yeah, we just measured the data. I'm a mechanical engineer, so please bear with me that I cannot go into detail how the impact of the shading is impacting the humidity. Yeah, it was data which we measured. We are really looking forward to publish this data. Yeah, because what I showed were preliminary results. Really looking forward to publish data to enable discussion, yeah, because here there are obviously it would be very interesting to also have the agronomic perspective on the data we are measuring below the PV panels. But as of now, I cannot give you deeper insights on why this data, why the humidity was measured like this.
Thank you, David. And the third question is from Oliver Niedhofer. He says, thanks for the great presentation. According to your research in Chile, which crop or fruits are best suitable to grow underneath PV panels?
Yeah, this is a great question, and it's a very important question. It's very important because it's in the end you have to find the best context for agrivoltaic system, and the best context is always the combination of the crop and also the local climate. Because when I want to grow, and I'll give you an example on blueberry in Germany, in in the south of Germany or in the north of Germany where it's rainy and cloudy, and the blueberry will grow. But when I plant the same blueberry here in Chile, it obviously will have a different result. Yeah, and here when we talk about suitable crops, I think we have many crops from fruticulture which are suited, especially berries, and blueberry is one of them, but also other kinds of berries. They are currently being produced in Chile with the aim to export them, and the farmers are investing in crop cover and crop protection. So here it would be very interesting to replace the crop protection systems they're using right now, the plastic covers, with agrivoltaic systems. So when you ask me for crops in more detail, blueberry is very interesting, but also apples are interesting. Cherry can be interesting, and grapes can also, table grapes can also be very interesting. All crops worth looking more into detail.
And the last question in chat is from Williams Panadero. He says, thanks for the presentation. And what is the cost of 1 kilowatt peak solar photovoltaic system in Germany?
Yeah, cost for photovoltaic systems. It's very very important question, and there's luckily there's data available on this. Yeah, it depends actually. Yes, it depends on the location where you are buying the components. For Germany, or I give you a worldwide reference, is that now normally you talk when you talk about 1 kilowatt of capacity, you talk about costs of less than $1,000. Yeah, it depends a lot on your system, on the size of your system. The bigger you make your system, the cheaper the price per kilowatt peak will get. Yeah, so when you just will install less than 1 kilowatt peak, it can be that the price is more than $1,000. Yeah, I think in Germany and in Chile prices are comparable. Yeah, it's not too big of a difference because in both countries we have a developed PV sector. Yeah, so there are panels available. When you want more data for the PV panel costs in Chile, I think the Ministerio de Energía, they published data for projects on rooftops. Yeah, and those are more small scale projects. And also the data is already 3 years old, so the costs are even lower. But this is a good reference for the upper limit in Chile. When it comes to Germany, I think Fraunhofer ISE, they are publishing regularly studies on the costs of photovoltaic systems. So I would recommend that you look on the more detail on the costs for photovoltaic systems, studies from Fraunhofer ISE.
Okay. And another question from Yusuke Amorota. Are there any EPC company who can design and construct agrivoltaic solar power plant with high length structure in Chile?
Very good question. As of now, there are no commercial projects. There are many companies interested in doing agrivoltaic projects, but I cannot name you one company as of now because there are no commercial references of built projects, and it would not be fair to just mention 1 or 2 companies which are interested. I know there are many companies interested, but please forgive me that I will not mention any names of companies now.
Okay, Frank, do you want to say something?
No, not really. I also would like to thank David for his nice presentation, and it was a great overview. We are looking for partners, especially EPC contractors, where we are doing the engineering, where we are doing the planning, and also analyzing for the crops and fruits which can be below the system. Also, you are not covering, as David already said, the whole area. You are shading some of the area. So you will not have 100% of electricity production like in a PV farm. But the benefit is that you use the ground below, and you also support, or you help the fruits or the vegetables to grow in their environment and their surroundings. And the other big benefit is really that you save water. And especially here in Chile, it's a very important point to use less water for irrigation, because water is a scarce product, and it will become drier and drier in Chile. So probably it makes sense to cover some of the area to use less water for irrigation.
Yes, that's so. Before finish this presentation or this session, we have another question from Oliver Nidhofer. What's, from your point of view, the biggest barrier for this technology to be rolled out in Chile? Question from David.
Biggest barrier, also a great question. I think there are some points where we're actively working on. Yeah, one fundamental barrier is obviously the know-how and the awareness of those kind of systems. Yeah, and we are in this form of this webinar. We are talking about agrivoltaic. Yeah, we're presenting it as a solution. Also, and this is very important, not only to the PV sector but also to the agriculture sector. Yeah, they have to know that there's this kind of solution available, so that we are generating interest, and then we can develop pilot plans. Yeah, so I think pilot plans are essential part to generate this know-how. Then when we look more ahead, I think it's also important to think about the legislation and the normative. As of now, in Chile, agricultural land is protected, is classified in various categories, but the good agricultural land is protected, so you cannot construct a PV plant, you cannot construct nothing on it. So here we have to clarify, and this is what we see also in Europe. For example, in Germany, they did a normative, a DIN norm, for agrivoltaic systems, which are integrating PV energy generation in agricultural land. It's not only PV panels above crops. It's like I showed, it's also PV panels side by side with crops. Yeah, but you have to make clear and have a norm on what is agrivoltaic. And based on this norm, we need legislation that allows us to construct these kind of systems, which as of now we don't have. So this is a huge barrier. We are working actively on this, in contact with politics, to show also the potential for agrivoltaic, to in the end to enable the commercialization of these kind of solutions.
Thank you, David. Now I will change to Spanish to finish this session. Entonces, gracias a David, gracias a Frank, gracias a todos los que nos acompañaron el día de hoy en esta sesión. No sé si David quiere despedirse también, aprovechando la oportunidad.
No, nada más que añadir. Muchas gracias por tenerme aquí. Yo siempre feliz de hablar sobre el agrivoltaico. Creo que es una solución con mucho potencial que prueba al fin dos necesidades básicas del humano, energía y alimentos, desde un sistema. ¿Ya? Y aquí en Chile tenemos, no sé si es la suerte, al fin es mal que estamos en una crisis hídrica, pero podemos con este sistema generar una solución también en términos hídricos, ¿ya? Y es algo que a mí personalmente me motiva, y si aquí ustedes están interesados en obtener más información o en colaborar, siéntense libres de contactarme y empujamos juntos este concepto en Chile.
Gracias, David. Gracias también a Frank por acompañarnos el día de hoy. Y ahí nos dejan en el chat un enlace para Fraunhofer Chile para seguirlos en Twitter, que nos pasen el dato.
Perfecto.
Así que muchas gracias a todos por acompañarnos, y recuerden que próximamente estaremos con más sesiones de W-ENER. Será informado a través del correo, así que nos vemos. Gracias a todos.
Chao, gracias.
Buen día. Hasta luego.